In this video, we're talking about exponential growth and decay. First, we're going to start with exponential growth. Exponential growth occurs when a quantity increases by the same rate over time. Now, that rate is going to be a percentage. So in this exponential growth equation, which is y equals p times 1 plus r raised to the power t, this is an exponential function where your base, 1 plus r, is bigger than 1, because 1 plus something is going to be greater than 1. Now in this exponential growth formula, this equation, p represents the principal amount or the initial amount, which is also your y-intercept. Now r represents the rate, the percentage rate. Now with your percentage, if you are given a percentage, remember that always means some amount out of 100. That's going to be very important as we change our percentages into decimals in just a little bit. Then your t represents some amount of time is what's going to go in the place of the exponent. And we'll see how this plays out in example 1. So the original value of an investment, that would be the initial value. So in this case, we can already say that our p is 1,400. Okay, and that value increases by 9%. So we know this is exponential growth because it's increasing by a percentage each year. Now that percentage, r, that rate, is 9%. But remember, a percent means out of 100. So this is really 9 out of 100. And if we divide 9 divided by 100, we're going to get a decimal number, and we want to change this percentage into that decimal in order to put it in this equation. So our rate is 9%, which is equal to 0.09. So this is what we're going to put into our formula. So we're going to write an exponential growth function to model this situation. So in our exponential growth equation, y equals p times 1 plus r raised to t, we know the principal amount was 1,400. Our base is 1 plus our percentage rate, which was 0.09 raised to t. Now t can be any amount of time as long as it's in years, because we were told that this rate applies to each year. So as long as t is in years, we can plug in however many years we want to find how much that investment is worth so many years later. Well, if we want to know how much it's worth in 25 years, then we're going to plug in 25 for t. So that will be 1,400 times 1 plus 0.09. So 1 plus 0.09, we can simplify that to make it 1.09 raised to the power 25. Now we can simply put this information right here into Desmos. 1,400 times 1.09 raised to the power 25. So to get a power in Desmos, you're going to click this a to the power b button. And when I click that, you can see that it moves my cursor up to the top of that parentheses. Now I can type in 25, and it is my exponent. So when we simplify, when we evaluate 1,400 times 1.09 raised to the power 25, we get 12,072 And since we're talking about money, we're going to round to 2 decimal places. So I have 0.312. That 2 is not going to round the 1 up, so we're going to leave it as $12,072.31. So the cost of tuition at a college is $12,000 and is increasing at a rate of 6%. So it starts at $12,000. So our principal is $12,000. The rate of increase is 6%. But remember, we want to say that's 6 out of 100, so what is that as a decimal? Right, 6 divided by 100 is 0.06. So our equation will be y equals 12,000 times 1 plus 0.06 raised to t. So it's important, again, to note that if it's increasing 6% each year, then our t is going to represent years. So we can only plug in years for t. All right, well, if we want to know the cost of tuition after 4 years, then we can plug in 4 for t. And simplifying this would give us 12,000 times 1.06. Now I got 1.06 by just adding 1 plus 0.06. And we're going to plug in 4 as the exponent for t. Now we're just going to simplify. So 12,000 times 1.06 raised to the power 4. That's $15,149 and 72 cents. So the cost of tuition after 4 years is $15,149.72. All right, number 3. The number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. So first we can say that the principal or the initial amount of students was 300, and the rate of increase is 8% each year. Well, 8% is 8 out of 100, so 8 out of 100 is 0.08. So to write this equation, y equals our initial amount times 1 plus 0.08 because it's increasing, and raised to the power t. Now, if our increasing rate is 8% per year, then we can only plug in t being in years. Well, we want to know the number of student athletes after 5 years, so we can plug in 5 for t. Just to simplify this a little bit, we have 300 times 1.08. And we got that by adding 1 plus 0.08. And we're going to plug in 5 for t. And now we're going to evaluate this. So 300 times 1.08 raised to the power 5. That gives us 440.798 students. Since we're talking about students, we can't have 0.798 of a person. So we're going to round this to the nearest whole number. If I'm approximating, we would say this is 440.798. But we're going to round to the nearest whole number. So we'll say this is 441 students because 0.7 will round the 0 up to a 1. Annual sales for a company are $149,999 and are increasing at a rate of 6% per year. Write an exponential growth function to model this situation. So what we know is that the starting amount of sales, or P, is $149,999. And we know this is increasing, so it's growth, and it's at a rate of 6% per year. So 6% is 6 out of 100, and 6 divided by 100 is 0.06. Now we know that that rate occurs each year, so T is going to represent years. So our equation, y equals the principal amount times 1 plus the percent rate as a decimal raised to the power T. Now in this case, since we already know that T represents years and we want to know the amount of sales after 7 years, we can plug in 7 for T. And we can type this into Desmos exactly as we see it. 149,999 times 1 plus 0.06 raised to the power 7. And that gives us $225,543, and we're going to round that to 4 cents. The population of a small town is 1,600 and is increasing at a rate of 3% per year. Write an exponential function to model this situation, then find the population of the town after 10 years. So our initial value is 1,600. The rate is 3%, but remember that means 3 out of 100, or 0.03. And T represents years because this rate increases 3% per year. All right, so our equation, y equals the initial value times 1 plus 0.03 raised to the power T, and in this case we're looking for the amount after 10 years. So 1,600 times 1 plus 0.03 raised to the power 10 is 2,150.26. So that 0.26, we can't have 0.266 of a person. So instead of saying 2,150.3 or 0.266, we are going to round this to the nearest whole number. That 0.2 does not round up the 2,150, so it's going to stay 2,150. And we're going to say that this is approximate. In number 6, in 1985, there were 285 cell phone subscribers in Mayville. The number of subscribers increased by 75% per year after 1985. How many subscribers were in Mayville in 2008? So again, we know that our principal value, our initial amount, is 285 subscribers. That rate of increase is 75%. So that means 75 out of 100, which is 0.75. Now for T, it does say that increased by 75% per year. So T represents years since 1985. Right, so we have Y equals 285 times 1 plus 0.75, and T represents the number of years since 1985. So to find T, what we're going to have to do is find out how many years passed between 1985 to 2008. So we have to subtract. (2008) minus 1985 is 23. So that's 23 years. So we're looking for Y equals 285 times 1 plus 0.075, or sorry, 0.75 raised to the power 23. All right, so we're going to plug that all into Desmos. 285 times 1.75 raised to the power 23. Wow. So our number of people who subscribed to a cell phone plan jumped from 285 all the way up to 110,845,988 people. So we're going to round this to the nearest whole number because we're talking about whole people. So that's 110,845,988 subscribers. Now we're going to look at exponential decay. So if growth occurs when a quantity increases by the same rate over time, exponential decay occurs when a quantity decreases by the same rate over time. And again, that rate is a percentage. Now the formula looks very similar. The only difference is now our base, because this is decay, our base has to be between 0 and 1. So our base is going to be 1 minus the rate, so that's going to be less than 1. The P still represents the principal or the initial value. The R still represents the percentage rate. And T still represents some amount of time. Okay, example 7. The population of a town is decreasing at a rate of 1% per year. In the year 2000, there were 1,300 people. So our initial amount, P, is 1,300. Our rate is decaying by 1% per year. Now remember, 1% is 1 out of 100, which is 0.01. And T represents how often does that rate occur. 1% per year, so years is our T. All right, so first let's write our equation to represent the situation. Y equals the initial amount times 1 minus, because it's decay, 0.01 raised to the power t. Now we're looking for how many people there were in 2008. So if t represents years, that's going to be 2008 minus the year that we started with, the year 2000. So that's going to be 8 years. So y equals 1,300. Now we're going to simplify this base. 1 minus 0.01 is 0.99. So it's important to remember that your base should be between 0 and 1. It should be less than 1 because it's decay. And now we just evaluate. 1,300 times 0.99 raised to the power 8. So that's 1,199.568 people. But since we're talking about people, we're going to round to the nearest whole number. So if this is 1,199.568, this 0.5 is going to bump that up to the next whole number. Now this one's a little bit tricky because when this 5 bumps this up to a 10, that bumps this up to a 10 and bumps the 1 up to a 2. So think it's bumping 199 up to 200. So 1,200 people. All right, in number 8. The value of a car is $18,000 and depreciating. So depreciating means decaying or decreasing at a rate of 12% per year. So our principal, our initial value is $18,000. The rate of decay is 12%. So 12% is 12 out of 100, which is 0.12. And if you're ever unsure about this, type it in the calculator. 12 divided by 100 is 0.12. And that rate occurs every year, so T represents years. All right, so Y equals P times 1 minus 0.12 raised to the power T. So we want to know the value of this car after 10 years. If we simplify this equation a little bit, 1 minus 0.12 is 0.88. All right, so now to type this in and find how much this car is worth after 10 years is 18,000 times 0.88 raised to the power 10. That's $5,013, and 0.17 would be 0.2, so 2 cents. All right, so we're rounding to 2 decimal places. So that's $5,013 and 2 cents, because the 0.17, the 7's going to bump the 1 up to a 2. A farmer buys a tractor for $50,000. If the tractor depreciates or decreases in value 10% per year, write a decay function to find the value of the tractor in 7 years. So our principal amount, it was worth $50,000. The rate of decay is 10%. So remember, 10 over 100 is 0.10. And T, that rate, occurs every year. So T is years. Okay, so Y equals 50,000 times 1 minus 0.10. And we're looking for that value after 7 years. So we can type all of this into Desmos exactly how you see it. You don't need to type the y equals, just the numbers that you're evaluating. So we have 50,000 times 1 minus 0.10 raised to the power 7. So that's $23,914.85 because the 845, that 5 bumps the 4 up to a 5. Okay, number 10. An investment of $8,200 loses value at a rate of 2% per year. Write an exponential decay function to find the value of the investment after 9 years. So the principal amount started with $8,200, $8,200, and it is decreasing or decaying by 2% each year. So our T represents years. Now remember, 2%, that's 2 out of 100, or 0.02. So our equation, y equals the principal, 8,200, times 1 minus the rate. And we're looking for this value after 9 years. Okay, so we have 8,200 times 1 minus 0.02 raised to the power 9. And we're talking about money, so we're going to round to 2 decimal places. So that's $6,836.73. Number 11, the value of a book is $58 and decreases by 7% each year. Write an exponential decay function to find the value of the book after 8 years. So our principal amount is 58. The rate of decay is 7%, so that's 7 out of 100, and that's 0.07. Then we have T. Well, that percentage occurs every year, so our time is in years. All right, so our equation, y equals principal times the base, 1 minus 0.07, and we're looking for that value after 8 years, so T is 8. So we have 58, parentheses, 1 minus 0.07, and our exponent is 8. So that's $32.46 if we're rounding to 2 decimal places for that change. 32.46. Number 12, the population in Haywardsville is decreasing at a rate of 2.5% per year. If the population in 2000 was 28,000, what will be the expected population in 2015 if that rate of decrease continues? Okay, so this one's worded a little bit differently, but it's the same process. The population, the initial amount of people, was 28,000. Okay, the rate is 2.5%. So that is still 2.5 out of 100. Now this one's a little trickier to just do in your head, so make sure that you actually type this in and see what you get. Okay, so now that's 0.025. Okay, now that rate occurs every year, so T is years. All right, well, let's go ahead and think about what T is going to be. So we were given the initial population in the year 2000, and we want to know the population in 2015. So that's going to be 2015 minus the year 2000 which is going to be 15 years. Okay, so our equation, y equals the initial amount, 28,000, times the base, which is 1 minus the rate percentage, which is 0.025, raised to the power 15 years. All right, so 28,000 times 1 minus 0.025 raised to the power 15. So that is 19,153 people, because we're talking about people, so that 0.5 is going to round it up to 153.